So hi, here we are again. Finally, you may say. Took a while, but now we are back with part 5 of our game development with Unity 2D diary. And in this episode, we'll discuss grids. And grids are at the core of so many 2D and 3D strategy games. And in fact, up to now, our Roman battle has been in continuous space, on a plane. But if we had an underlying grid, we could more easily create an AI with a smart strategy and also other advantages. Now, grids are everywhere in video games. They're not just in in strategy games. All sorts of games, match-free games, puzzles, role-playing, all sorts of games use grids. So grids, they indeed should be in your set of tools. Now, one of the tradition in grids in video games is using hexagonal grids, in particular in strategy games. And well, this is because on one side, grids simplify things, but they can also give the player a sensation of oversimplifying things in the way that you move in space. If you just can move front, back, and sideways. And so with hexagonal grids, you have more natural, also sideways, diagonal movement. And you also can take into account that the diagonal movement should reach with respect to the front of your battle or of your game, should not reach in front as just like a front movement. So in other terms, it accounts to the fact that the distance between the center of each hex cell and the center of all 6 adjacent hexes is constant. So what you gain on sideways movement, you lose in front movement. Okay, so it seems that for human beings, hexes, a grid in hexes gives a sense of continuity of space, and while keeping the space of possibility not too complex. And in fact, the tradition of using hexes in video games comes, and using grids in general, comes from board games, of course, where using continuous space would make things impossibly complex. But in fact, it results even where we can deal with an emulation of continuous space. It actually gives a UI improvement, a usability improvement for people and AIs. So we still use grids. Now, not only hexagonal grids, as someone pointed out. If we really want, we can go into even more complex kind of grids. And what's cool is that it's very easy to design maps with grids, and also to generate them algorithmically or procedurally, as we like to say in games. And of course, we're not limited to 2D. While here in the next part, the following part of this video, we cover 2D, you can indeed use grids, probably even more forced to use grids for 3D space. So how can you get to have a grid in your own game, in your own 2D game? Well, one way is, of course, going to and developing your own grid. In particular, if you're going to develop a hexagonal shaped with units of hexagonal shape, this is not going to be trivial, because there's nothing in Unity built in to help you in this. So you have to build everything by yourself, and building the shapes, the movement, the computation, the A-star, whether if you want to have spaces between hexes or not, borders, and in particular mapping Unity points to pixels to hexagons won't be trivial. It's not impossible, not trivial. And I give you here some links on some wonderful tutorials for doing this, but this will take surely a long time. So instead, what we're going to do here, we're going to look at a component. So one of the wonderful things about Unity is this: it's not only it is pluggable, in potentially pluggable, it's been plugged. So there's enormous community of developers providing solutions, and this is a typical one. So that you can, again, as we said several times in these tutorials, we're trying to focus on building the game, not solving the entire spectrum of mathematical problems that arise in building video games. In fact, that's the philosophy of adopting Unity in the first place. Otherwise, one could go in C++ and not using an engine at all. So the component that we're going to consider is by Game Logic. It's called Grids. It's a truly wonderful plugin because it solves a large, wide set of problems in an elegant way, and it's quite it's not trivial, but quite simple and powerful to use. And so this component Grids comes with also several algorithms built in: shortest path, connected shapes, connected lines, neighborhoods, aggregation, A star, and it can makes it easier to solve problems like handling very large grids, generational grids. It handles both uniform grids like the one we've seen up to now, and splice grids, so grids that you generate by cutting a space in pieces like rectangles. And in the latest release 1.8, now you can actually build grids not only via code, but directly visually in the editor, which is really cool. So let's go into the detail of this component. So once you open Unity and download or import the package, it actually comes with a lot of wonderful examples. So if you go into the scenes, you will find examples, so you'll be able to run them. They're divided into grids in the editor, so that you can visually preview them in the scene and build them in the scene view, and grids built only with code. And so I've opened Lightside Cairo, which is the grids in the editor games, as one of the example provided. So here you see that basically a grid is an array of points. Points are a set of coordinates. Now in this case it's already complex because we have three dimensions, and so if you run it, so you see how it goes, and it does really a lot of refined stuff considering connectedness and the particular shapes of the cells. And so here cells are simply made by coordinates and a Unity 2D native sprite, which we by now know very well how to use. And so basically how you use it is that you have to provide a class which implements the cell. So for given a point, a set of coordinates in the grid, from the grid you can use the grid as a map. You apply the grid to the point and you get the cell, and the cell is in fact your own implementation. So well, this example it looks already quite complex, and we'll soon go back to our Roman battles, and we'll implement there a very simple grid. In the grids component, they themselves, I asked them, and as usually they answer almost immediately, and they gave me like the main set of math problems that we solved, and that so that you don't have to solve them yourselves, because you'll have enough problems developing your own game and the specific game logic. And so they saw working with the grids of various shapes and the mapping of space to the grid. And one thing I've been beginning to understand, and probably you will too, is that if you're using grids in games, most often you're not only using a unique grid, so the graphical grid and the logical grid, like the grid of waypoints, of paths, there may be more than one and even several grids in the same game. Okay, so another cool thing is that by the way it's built, as you plug in your own cell notion, you also plug in your own graphical notion of cell. So actually I tried it. Works fine with NGUI, with Natives 2D, 2D Toolkit, and so that's really cool, because I mean they solve a certain set of problems, but they don't solve too many problems. So let's go back to our Roman battles. So back to Unity. So back to our Roman battles project. And well, first thing I did here was to, of course, import the plugin game logic grids, and now when you import it, it will import also the examples, so an enormous amount of stuff which you don't actually need. Now when you want to get rid of the examples, you will need, there's actually a dependency between the plugin and some code in the examples, like 4 classes. They're generic tool classes, and they actually will fix this in next release. But anyway, you'll have to copy these 4 classes inside your own code before getting rid of the examples. So but anyway, so let's say you imported the package. Well, the first thing you have to do is to create an empty game object, which I call Teutoburg grid, and on it add the component which is grid builder. I already extended their own grid builder with a Roman grid builder, which does nothing but make it available statically to all other classes, as we are used to, as we did many times in the other tutorials. So notice that Roman grid builder is extending pointy hex style grid builder. Now they provide many kind of builders depending on which cells you want to use. As for the tradition here, I want to use hexagons. So that's what I did. And once you have the builder script, it does magic for you, because it can generate the cells, it generates the alignment, so you can see it in the scene view. And this done, you notice here you have to tell a cell prefab. Here Roman pointy hex, which I should have here, which and on the prefab which you specify, so in prefab I used a cell, actually one of the sprites provided in the examples, but here there's a crucial point. So on the prefab you associate your implementation of cell, so in my case Roman Sprite Cell. And let's check out the code. What does Roman Sprite Cell do? Well, first of all, it extends Sprite Cell. Now in this, because in this particular grid usage of the grid component, we're using 2D and we're using Sprite cells, but there are many other kinds of cells that you can extend, even more primitive ones. And what we do? Well, what we do, we do based on click, because Sprite Cell provides the simple fact that that the cell changes color when clicked, when selected. and we may simply find so if you're clicking on a cell which is not the cell where our only unit, this Roman cavalry unit, is, if you click on another cell, the idea is to move the cavalry unit from that cell to another one, which we do with this code. I actually did several versions of this call, which uses the A-star implementation provided by the component in order to show different features. So it actually closes here. The code is a bit strangely written, but so I can enable more refined, more powerful kinds of calls without using all the defaults, as we are doing here. So let's just see it in action for the first time. Yeah, so we have our grid, we have our friend the cavalry, and if I click here, if it's reachable in 2 steps, it actually would go there, but if it's further, nope, with 1 step, yeah, 1 step here. Okay. So we have the grid component is giving us matching clicks, where to goes, mapping space to grids, and also giving the star implementation. Now how is this called, or this written? Well, so I had my grid, I recover my grid here, so I call algorithm A star is a static call, and I have my path, which is a path of points. So I'm here actually only using the length, but you actually have all the points of the shortest path, which is cool. So you could segment movement along the chosen path instead of cutting through as I'm doing, and that's it. So distance, and whether each path, the distance and the walkable paths is all implicitly defined. What I mean by walkable paths is that, well, simply the fact that here, in the example that we're seeing, we have no obstacles, but we could put obstacles and the algorithm would work just fine. In fact, there's a little animated GIF here showing you on the blog post how this, to give you the intuitive idea how A star works, but this is completely out of scope. Now, so we could write the code more explicitly. So this is our second version, so passing more arguments, but this should change nothing in how it actually works, because here we're passing the distance function, and whether a certain each of the cells is actually walkable. Here we're simply saying every cell is walkable. If I save, restart, nothing should change. Okay, it took a while. Okay, and nothing. If I go too far, that's it. Okay, if I go back to code and I can have a different way of saying whether a cell is walkable or not. So we save, and what I'm saying here, I'm being silly, but just to show you, I'm saying that a cell is walkable or not depending to a random function. So it's walkable if the random range between 0 and 5, these are integers, is below 3, below or equal to 3. So if I run now, I did save. Yeah, I did save. So if I run now, you see the scene is auto saved thanks to a plugin we've seen in a previous component. Now if it's running, not yet. Yeah. Okay. Let's see if it works. It doesn't. This is walkable, but by some mysterious random factor, it's not making me walk. But so if I go here, okay. Now I click again. Okay, sometimes works and it doesn't. This I introduce a crazy random factor that it's just what sometimes games needs. But this is just to show you how to use the signature. But of course, well, I'm writing this. You could write this in a more compact form, but that's entirely, I mean, not that interesting. But the point is that you can pass a function here. So you just create a static function here. And what's cool here that it takes a cell. So the algorithm could ask the cell if the cell has like, if cell dot has a building in it, then it's not walkable. And so here I show you how you would implement that. But here we just use the random factor, but you could like do animation of a little ghost showing up. Let's save it. Let's see whether it works. So let's start it again. Wait, see, because it's actually checking all the possible paths. So yeah, it worked. It worked. Yeah, it didn't work. Okay, some ghost came out here. So anyway, this is just a really beginning, but it's actually it seems simple, but an enormous amount of problems have been solved just by using the grid and extending it appropriately. Let's see if I forgot something. Well, of course, we haven't seen it, but grids supports works just as fine with 3D worlds. And there's only one problem, I think, in this component yet, is the lack of a user guide. It has examples, it has an API, the code is documented, but it lacks something that guides the user, in particular beginning user. So I hope that the authors, who have indeed been providing more and more documentation the last few months, will also provide like a reference user guide, because also the code is developing quickly, and sometimes you don't know whether it's the right code or not. So I think this is all for today. Of course, I mean, the focus has been more on the grid than on the battle, but of course, having this grid and solve this problem, one can build beautiful battles on this hexagonalized universe. So as a final note, I'm using the grids in order to develop my two games. One is of course Genio, the game on the Renaissance, where towns are built along a spiral. Spiral grids are entirely non-trivial for their own geometric reasons, and also for the People in Love game, which will be an iPhone game based on a square grid. So well, anyway, so I hope you enjoyed this, and we'll keep in contact. I mainly use Twitter and People Sinelli. So see you soon. Bye.